2.3 Silicon crystals. When silicon atoms combine to form a solid, they arrange themselves into an orderly pattern and is called a crystal. Every neighboring atom shares an electron with the central atom. In this way, the central atom has 4 additional electrons, giving it a total of 8 electrons in the valence orbit. The electrons no longer belong to a single atom. Each central atom and its neighbors share the electrons. The same idea is true for all other silicon atoms. In other words, every atom inside a silicon crystal has 4 neighbors. In the figure on the left, each core has a charge of +4. Look at the center core and the core on its right. These 2 cores attract the pairs of electrons between them with equal and opposite force. This pulling in opposite directions is what holds the silicon atoms together. This idea is similar to tug-of-war teams pulling on a rope. As long as both teams pull with equal and opposite force, they remain bonded together. Since each shared electron in the figure is being pulled in opposite directions, the electron becomes a bond between the opposite cores. We call this type of chemical bond a covalent bond, and this is shown on the picture on the right. It's just a simpler way to show the concept of covalent bond. In a silicon crystal, there are billions of silicon atoms, each with 8 valence electrons. These valence electrons are covalent bonds that hold the crystal together. Each atom in a silicon crystal has 8 electrons in the valence shell. These 8 electrons produce a chemical stability that results in a solid piece of the silicon material. When the valence orbit has 8 electrons, it is called saturated because no more electrons can fit into this orbit. Stated as a law, valence saturation means there are 8 valence electrons. Now let's discuss a very important concept in semiconductor, and it's called hole. It is created by leaving or departure of electron in the crystal. If you look at this picture here, there is one electron flowing out from that silicon material. The E is the electron, and the -1 means it carries -1 charge. It's outside that region, and then that green circle represents the hole. So the departure of the electron creates a vacancy in the valence orbit, and this is called a hole. There are several ways to cause the electrons to leave the home and create a vacancy, the hole. And one way is to provide thermal energy, which means the heat. So heat creates an equal number of free electrons and holes in the silicon crystals. Recombination is the merging of free electron and a hole. As shown in this simple animation, as you can see, the electron that's outside the region is a free electron, where free electrons means electrons can freely move in the material. And once there is a hole, the electron just enter and fill that hole. This is due to electron carry negative charge, and the region of that hole actually is the hole carry a relatively positive charge, and they attract each other. Since they attract each other, electrons continue moving and filling that hole. In a pure silicon crystal, thermal energy creates an equal number of free electrons and holes. That means we can apply heat to the silicon material. If one electron starts moving out from the region, there must be one hole being created. If there's one more electron, that means two electrons moving out from the region, there are two holes being created. So the number of electrons moving away from the silicon, there should be same amount of holes being created. In summary, some free electrons and holes are being created by thermal energy. Other free electrons or holes are recombining. Some free electrons and holes exist temporarily awaiting recombination.